Hello, everyone, and welcome to the Chapter 8 overview. The chapter is called Enlightened Science II, Progress on All Fronts. But before we get to the overview, I'd like to talk a little bit about the upcoming midterm. Please note and remember the following things. The midterm dates are either Tuesday, October 20th at 4 p.m., I'll email you the location later this week, or Thursday, October 22nd at 1 p.m., Again, location to be emailed. If you can't make either of those dates, it's very, very important that you contact me at the email in the next bullet point and make arrangements. The first paper is due the following week on October 30th. That's the paper that has to do with one aspect of the scientist. All the details are on our Blackboard site. And when you're done with that paper, please email it directly to me at that email, my Temple email. Remember also the week following the midterm, we have an optional field trip to the Wagner Free Institute of Science. That trip is on Thursday, October 29th, 1 p.m., and if you would meet me at the Wagner lobby at 17th and Montgomery. It's a real quick walk from campus. It's a 3-block walk west from Broad on Montgomery, and I hope many of you guys can make this trip. I know one or two people are going to meet me at 2 o'clock because they can get there by 2:15 or so, and we're going to do a kind of a mini trip after the 1 p.m. Presentation. Okay, let's get to this chapter, Chapter 8, which is the last chapter before the midterm, the focus topics and pages for this chapter. Now, there's a lot of people, again, in this chapter, but I just want you to focus. I'd like you to read the entire chapter, but I'd like you to focus for the midterm on these two sections. On the study of electricity, which is pages 285 through 292, and the study of the age of the Earth, which are pages 312 to 315. So there's not quite as much reading for the midterm on this particular chapter. Stephen Gray, Charles Dufay, Benjamin Franklin, and Charles Coulomb in the first part in the study of electricity. And very important are two men by the name of Luigi Galvani and Alessandro Volta and the invention of the battery. The battery was key to moving a lot of technologies forward over the last few hundred years. And then a scientist who has a big influence on Charles Lyell, we'll read about later, and Charles Darwin, and his name is James Hutton. So let's get started. One of the things that's mentioned in the chapter is the fact that a scientist by the name early on, Muschenbroek, who was working in the city of Leyden, invented something called the Leyden Jar. People who were studying electricity wanted to find a way that they could store static charges. And this device allowed them to store a lot of static electricity, so much so that it could literally kill small animals. Now, this is an actual Leyden jar here, but it doesn't explain how it works. So let's go to the next page, and it talks, basically a Leyden jar is a capacitor. It just stores and stores and stores electricity. So there's a metal rod, there's a non-conductive top. You'll see the outside of the jar has a metal coating on it, and that's what stores the negative charge. The inside is where the positive is stored, and then there's a little chain that goes down to the bottom. So that's what a Leyden jar looks like. Well, with all these people studying electricity, there were bound to be accidents, and Georg Richmann, a German, decided that he wanted to try and capture not just electricity in a jar, static electricity in a jar like the Leyden jar. He wanted to capture lightning. Not a good decision, and proved fatal for him. Our own Philadelphia Benjamin Franklin did a number of experiments on electricity. They were made in Philadelphia. The experiments were made in Philadelphia, published in London. Here's an old Currier and Ives picture of Franklin and his famous key experiment. And Franklin was very practical, though. Not only did he study the theory of what electricity was, but one of the major problems with electricity, static electricity in the form of lightning, was that it would cause fires. And if we were a rural nation at the time, so if lightning hit your barn or your house, it was up to you and whoever was living in that house to try and put it out, especially because your neighbors were so far away. So Franklin invented the lightning rod. And it was a very, very famous invention at the time because what it did is You put a metal rod at the top of your barn or your house, and if lightning did strike it, it would be discharged into the ground. In other words, the lightning would go down that copper cable all the way down into the ground, and your barn or your house wouldn't catch fire. Huge invention for rural America back in the 1700s. The next scientist that I'd like you to focus on is Luigi Galvani, and the chance discovery of what happens when a scalpel that has a little bit of electrical charge hits the leg of a frog. Now, that's a really chance happening, but Galvani discovers that the frog muscle would jump, and he realized and started putting together the fact that electricity controls body function, especially in muscles. Muscles like our heart, muscles that are all over our body, in our legs, in our arms. In this diagram, you'll see a Leyden jar on that table to the right. You'll see the frog's legs there in a couple different places, but you'll also see a round device on the left-hand side of that table. That's another way to generate electricity, sometimes called a Wimshurst machine, and that generated electricity would then be stored in the Leyden jar. One of the most famous scientists that invented something very practical was Alessandro Volta. He invented the battery. And if you look at the right there, that tall pile there of different metals, that's one of the earliest batteries that were ever made. And I'm going to show you a diagram next of what the battery was. There were two metal parts, zinc and copper, and then in between them would be a electrolyte. It might be salt. Usually salt would be in between there and would help move the electricity. The top of the voltaic pile would be negative and the bottom would be positive. So this is what an early battery looked like. Batteries today have chemical paste in them, but they still have zinc and copper. It's one of the reasons why they're so heavy. So they're small and they're heavy. So please make sure you read up on Volta. And then we have a complete change into a scientist from Scotland by the name of James Hutton, who studied the age of the Earth. Up until this point of time, most people thought the Earth was old, as in the terms of thousands of years. But it was Hutton that started to say, no, I think all these processes we see, like volcanoes and mountains and the layers of the Earth, all of this could happen through natural processes. The same processes that took place millions of years ago are taking place today. It's just that they're very, very slow and that the Earth is very, very old. So one of the things that Hutton did was he coined a phrase, uniformitarian, which means everything's the same process. As a matter of fact, there's a biography written by the father of a Temple student called The Man Who Found Time, James Hutton and the Discovery of Earth's Antiquity. Now, Hutton's important because of his influence on a geologist by the name of Lyell, who we'll read about a little bit later after the midterm. And Lyell was a big influence on Charles Darwin, so we'll have a chance to read that. So again, guys, remember, please note and remember the midterm dates are either Tuesday, October 20th at 4 p.m., Thursday, October 22nd at 1 p.m. I'll email you those locations. The first paper is due the following week, Friday, October 30th. Email the paper directly to me. Details are on our Blackboard site. Remember, it's the paper about one aspect of a scientist that you find interesting. The descriptions are on the Blackboard site. And the optional field trip to the Wagner Free Institute of Science. Thursday, 1 p.m., meet me at the Wagner Lobby, 17th and Montgomery. Short walk from campus, and I hope many of you can make this trip. Hope you're enjoying the book. That's going to be the end of all of our reading for the first half, and we'll pick it up after the midterm with Chapter 9. We've read 8 chapters for the midterm. For the final, we'll only be reading 6 chapters. We'll read chapters 9 through 14, so it's a little less reading in the second half. But remember that we also have a final, and we have a second paper that comes up near the end of the course. Thank you very much, and we'll see you for the midterm.